Welcome to The Explainer. Today, we're tackling a concept that is literally everywhere right now: sustainability. We're going to strip away the corporate buzzwords, the marketing spin, and the greenwashing, and we're going to look directly at the math and the science. We want to uncover exactly how true sustainability is mathematically quantified by academic researchers and industry experts. Because let's be real, it's not just a vague feeling, it's a rigorous formula. Here is our roadmap for today. 1. Defining true sustainability. 2. The sustainability equation. 3. Pillar 1, which is environmental impacts. 4. Pillar 2, life cycle costs. 5. Pillar 3, social reality. And finally, 6. Solving the assessment puzzle. All right, let's jump straight into section 1, defining true sustainability, from 18th century forests to global policy. So we really have to start with this foundational question. What exactly is meant by the notion of sustainability? It's a word everybody uses, right? Politicians, CEOs, us as consumers. But to truly measure it, we have to challenge our baseline assumptions and understand where this concept actually originated. Because spoiler alert here, it definitely wasn't invented in a 21st century boardroom. Let's actually look way back to 1713. A guy named Hans Carl von Carlowitz, who, by the way, wasn't even an environmentalist. He was a superintendent of Saxon silver mines, was super worried about timber shortages. He essentially proposed that you should only log as much wood as the forest can actively regenerate. That is sustainable forestry right there. Fast forward to 1987, and the famous Brundtland Report takes this and scales it up globally. They defined it as meeting the needs of the present without compromising future generations. Then, in 1991, the scientific community, specifically the SATAC Symposium, really began heavily restricting life cycle assessments, mainly to environmental impacts. But as we're going to see today, true sustainability is a whole lot bigger than just the environment. Which brings us to section 2, the sustainability equation. We're going to break down what modern industry calls the triple bottom line. Think about this paradigm for a second. Our entire human technosphere, and by that I mean our micro and macroeconomics, our social participation, our justice systems, our manufacturing processes, all of it is completely embedded within the natural ecosphere. They are totally inextricably mixed. You literally cannot have a functioning economy or society without a functioning natural world. It really proves that any genuine assessment of a product has to look at how all these spheres interact with one another. So, here is the absolute anchor of our entire explainer, the LCSA formula. LCSA stands for Life Cycle Sustainability Assessment, and to solve it, you have to add together 3 separate assessments: LCA, which is the environmental impact, LCC, which is the economic cost, and SLCA, which is the social impact: people, planet, profit. Let's go ahead and break down each one of these variables. Section 3, Pillar 1, Environmental Impacts. Let's solve for the LCA variable, which is definitely the most well-known part of the equation. When researchers run a traditional environmental life cycle assessment, or LCA, they are primarily looking at factors like climate change, ozone depletion, acidification, and human toxicity. You kind of notice a trend here, right? Traditional LCA has what experts call a heavy chemical preponderance, meaning it focuses almost entirely on chemical emissions and their physical effects on the environment. But honestly, that's only part of the story. Contrast that heavy chemical focus with the biological impacts, which are severely under-researched. For example, did you know that invasive species are the second-ranking cause of extinction of native species worldwide? Yeah. Think about a massive cargo ship carrying products across the globe. Its ballast water might be carrying non-native organisms, neozoa, that can absolutely devastate a local ecosystem. A truly comprehensive LCA has to account for these massive biological disruptions, not just the chemical exhaust coming out of the factory. Moving on to Section 4, Pillar 2, Life Cycle Costs. Now we're solving for the LCC variable in our equation, because let's face it, for our product to be truly sustainable, it also has to be affordable and profitable based on real money flows. Now, before we can calculate those costs, we have to clear up a crucial terminology difference that honestly ruins a lot of data. When a marketing department talks about a product life cycle, they usually mean the period from R&D until the product is pulled from the store shelves. But in sustainability math, we need the physical cradle-to-grave definition. We have to track the costs starting from the extraction of raw materials in the ground all the way to the product's ultimate end-of-life disposal or recycling. If you don't track the actual physical timeline, your cost assessment is basically useless. That brings us to Section 5, Pillar 3, Social Reality. This is where we solve for the SLCA variable, the Social Life Cycle Assessment. This is the newest and arguably the most difficult pillar to figure out. It acts as a massive corrective measure. Just consider this for a second. A product might be totally green, producing zero carbon emissions, and it might be incredibly cheap to manufacture. But is it sustainable if it relies on exploitative labor? The answer is an absolute no. Environmental and economic metrics become completely meaningless if the production involves human rights violations, child labor, or dangerous working conditions. We have to quantify human well-being. But how do you actually quantify something as complex as human well-being? Well, one really fascinating approach by researchers like David Hunkler is life cycle working time, or LCWT. The idea here is to look at how much human work time goes into making a single product, and then combine that with local wage data. This gives assessors a measurable baseline to compare products and determine if a financially favorable item was, only made possible through the exploitation of low-wage manpower. It takes a moral issue and transforms it into a measurable metric. Now, this is a super active area of research right now, and there isn't just one magic way to measure this yet. You've got Hunkler's work time method, then you have frameworks like CE Balance, which was developed by companies like BASF, creating a 3D cube, plotting eco-efficiency against social data, and then you have the UNEP/CTEC guidelines that mix quantitative data with qualitative valuations. It's a highly complex social variable, and academia is actively competing to find the absolute best way to operationalize it on a global scale. Finally, Section 6, Solving the Assessment Puzzle. We have our three variables. Now let's put the whole LCSA formula together. So how should these three pillars actually interact in the real world? Well, the research presents two major academic options. Option 1 is to keep the three assessments entirely separate. This maintains absolute transparency. You can clearly see the pros and cons in the environment, the economics, and the social spheres, without one outweighing or hiding the other. Now, option 2 is to create one massive, combined model, often referred to as an LCA2, which integrates cost and social metrics directly into a single environmental impact assessment. Option 1 keeps things incredibly clear, but option 2 might be easier to conform to international ISO standards. It's a huge ongoing debate in the scientific community right now. I want to leave you all with this rather stark warning from the Advisory Board for Sustainability in Germany. Sustainability without quantified goals threatens to evolve into an empty phrase. This right here is exactly why calculating the rigorous LCSA formula matters so much. If we don't have hard numbers for the environment, the real-world costs, and the human social impact, we leave the door wide open for corporate greenwashing. So the next time a company tells you their product is sustainable, ask yourself, have they actually done the math? Thanks for joining me on this explainer. Keep questioning the metrics, and I'll catch you next time.